When it comes to elastic collisions, momentum is conserved. Momentum is conserved in all types of collisions, provided they're both closed and isolated. In an elastic collision that involves two bodies, we can state as an equation that the total initial momentum, that is the momentum of two separate objects added together, is equal to the total final momentum. Take each of the two objects' final momentum, add them together. Initial momentum, final momentum are equal. Often you have to solve for two variables in a problem like this. You've got to find out the final velocity of both objects, yet there's only one equation. But there's a second equation that says relative velocity is conserved in an elastic collision. Well, it's not totally conserved. It's conserved in magnitude, but it changes direction. A special case of this occurs when you have one block moving to the right with a speed, we'll just call it u, and then it collides with the second block that's initially at rest. And furthermore, if the first block has a mass of m and the second block is 3 times as massive, then you get a fairly interesting result. So let's apply the equation for conservation of momentum to this problem best we can. We have m times u plus 0 is equal to m times v1 plus 3m times v2. Okay. Additionally, the relative velocity is conserved. We can state that as an equation as u minus 0 is equal to the negative of v1 minus v2. So u is equal to v2 minus v1, or in other words, v2 is u plus v1. And we can use that to substitute back into the original equation that stated conservation of momentum. So let's see what we get. M times u is equal to mv1 plus 3m times the quantity u plus v1. So we have mu is equal to 4mv1 plus 3mu. Suppose at this point we can cancel out m in every term. If we subtract 3u from both sides of the equation, we find that negative 2u is equal to 4v1, or in other words, the result is the final velocity of object number 1, which is the one that was initially in motion. Object 2 is the one that was at rest. Object 1 was in motion, and its final velocity is equal to negative 2/4 of its original velocity, or in other words, negative 1/2 of its initial velocity. Negative meaning it reverses direction, and 1/2, of course, means it's not moving as fast. And by the way, then, what would v2 be equal to? Well, as we saw earlier, v2 is equal to u plus v1, so v2 is u minus 1/2 u, which gives us positive 1/2 u. So to illustrate this, we could say a block of mass m is moving to the right at 10 meters per second and collides with an object of mass 3m that starts out at rest. And then for a brief moment, the two objects slam into each other. There's no loss of mechanical energy in that process, and then the two go flying apart. The block with mass m moves to the left, the block with mass 3m moves to the right, and the speed would be negative 5 meters per second and positive 5 meters per second. I have another video where I've illustrated this with actual demonstration equipment, so please take a look at that video.